Student of plus 11 and 12 may be alerted that they are in the battlefield alone to conquer their dreams or ambitions. They should have Falcon dream to reach the goal. Success is waiting for you. Student, go ahead with preparation for fighting alone to pack your dream, abstaining from all social media, friendship, and all relationships for a negligible part period of whole life. For a negligible part period of whole life, prepare yourselves and strengthen your wisdom. Mole concept is a very basic chapter of chemistry. The chapters like solution and colligative properties, kinetics of gaseous system, thermodynamics, chemical kinetics, chemical equilibrium, electrolysis, etc. will not be cleared properly without the sound knowledge of mole concept. Actually, mole concept is a basic lesson of last 10 of ICSC board, and in 11 and 12 the chapter have been explained in detail. Now let us start the understandings of mole concept. Hydrogen atom, hydrogen molecule, and hydrogen ion. 1.008 gram. This is gram atomic mass called 1 gram atom. Hydrogen molecule 2.016 gram or gram molecular mass, or may be called 1 gram molecule. Hydrogen ion 1.008 gram ionic mass or 1 gram ion. This hydrogen atom, that is 1 gram atomic mass or 1 gram atom, is contained 6.023 into 10 to the power 23 number of atoms. Hydrogen molecule, 1 gram molecule contains 6.023 into 10 to the power number of molecules. Gram ion contains same number of ions. Similarly, in case of oxygen atoms, gram atomic mass 8.0 gram molecular mass, oxygen molecule O2 molecule 16 gram, and oxygen ion 8 gram ionic mass. This gram atomic mass, this gram molecular mass, and this gram ionic mass also contain 6.023 10 to the power 23 number of atoms, number of molecules, number of ion also. Hence, it may be say conveniently that 1 gram atom, 1 gram molecule, and 1 gram ion is the gram atomic mass, gram molecular mass, and gram ionic mass of respective atoms, molecules, and ion. From above example, it is clear that 1 gram atom, 1 gram molecule, 1 gram ion contains same number of particles, that is 6.023 into 10 to the power 23 number of atoms, number of molecules, and number of ions respectively. This number is called Avogadro number and represented by a capital Na. Therefore, mole can be defined as the quantity of substance contains 6.023 into 10 to the power 23 number of particles, and particles are in the form of atom, molecule, or ion also. It may also be stated that 1 mole of carbon 12C has exactly 12 gram of weight, and has 6.023 into 10 to the 1 number of particles, that is atoms. Previously, the lecture given is applicable for all types of substance that exist in the solid, liquid and gaseous state. The element in the gaseous state may also be defined by their molar value. From Avogadro hypothesis, 1 mole of gaseous molecule occupies 22.4 liter or 22400 ml per cc at STP. That is standard temperature and pressure. Standard temperature is 0 degrees centigrade or 273 Kelvin, and standard pressure is 760 millimeter of mercury or 1 atmospheric pressure. As for example, 16 gram of O2 or 1 gram mole of O2 occupies 22.4 liter at STP. Therefore, 22.4 liter of O2 at STP is also called 1 mole of O2. This concept may apply in solving numerical. For a gaseous molecule as STP, it can be rewrite that 1 mole of gaseous molecules is equivalent to 1 gram molecular mass, 22.4 liter of gas at STP, 6.023 into 10 to the power 23 number of molecules. Now some problem, some numericals on mole concept. How many number of molecules and atoms in 64 grams of oxygen? Answer: 64 grams of oxygen is equals to 64 by 16, whereas 16 is the molecular mass of oxygen and 64 is the given mass of oxygen, that is equals to 4 mole. Therefore, number of molecule in 4 mole, 4 into 6.023 into 10 to the power 23, that is equals to 24.09 into 10 to the power 23 numbers. Since 1 moles contain this number of molecules, Avogadro number of molecules, 1 molecule contains this number of molecules, therefore 4 mole contains 4 into this. Now, every oxygen molecule consists of 2 atoms, diatomic, therefore number of atoms 2 into 4.6023 into 10 to the power 23, that is 48 point this number of atoms. These two comes from number of atoms in one molecule of oxygen. Therefore, 2 into 4 into 6.0223 into 10 to the power 23. Calculate the mass, number of molecules and number of atoms in 67.20 liter of water at STP. Now, we have to convert this liter of water at STP, convert it into number of moles. 67.2 liters of water at STP equals to 67.220 by molar volume, that is 22.40. We get 3 moles of water. 1 mole contains 6.023 into 10 to the power 23 number of molecules. Therefore, 3 mole contains this number of molecules. And this number of molecules is equals to 3 into 3 again. Number of atoms. These 3 comes from water molecule, which consists of 3 different atoms. 1 atom of oxygen and 2 atom of hydrogen. These 3 comes from these 3 atoms of water molecules. Now, mass of 67.20 liter of water. 67.20 liter of water is equals to 3 moles of water. So therefore mass of 3 moles of water equals to 3 into 18 equals to 54 gram. 18 is the gram molecular mass of water. Next, mole concept and mole fraction in terms of concentration. Mole concept and mole fraction in terms of concentration. Now here 2 beaker is taken of different concentration of sulfuric acid water. A solution of sulfuric acid to different concentration. In this solution A, that is beaker A, 180 gram of water, and another beaker 135 gram of water is taken, and a beaker A 147 gram of H2SO4 and 122.50 gram of H2SO4 for beaker B. Now mole fraction in 2 figure is given here. One beaker contained 147 gram of H2SO4, which is called solute, and 180 gram of water pure, which is called solvent, and other beaker contained 122.50 gram of H2SO4 solute and 135 gram of water, which is solvent. Here Na, mole of solute is represented here, small na, A for solution A, and capital Na is the moles of solvent, and A for solution A. And next, Nb of moles of solute of solution B, that is here, and capital Nb moles of solvent of solution B in this beaker. Now moles of solute of H2SO4 in beaker marked A, 147 grams of sulfuric acid, that is weight of sulfuric acid given by 98 is the gram molar mass of sulfuric acid, is equals to 1.5 mole, represented by Na, and number of moles of solvent H2O in beaker marked at A, 180 by 18, where 18 is the molar mass of water, 10 mole, represented by capital Na. Therefore mole fraction of solute, that is H2SO4, is 1.5 by 1.5 plus 10, that is 10 moles of sulfuric acid, and mole fraction of solvent H2O, that is 10 by 1.5 and 10 by, that is total mole in denominator, moles of water and moles of sulfuric acid and moles of water, moles of solvent, and in above 1.5, which is moles of sulfuric acid, and total mole sulfuric acid, moles of sulfuric acid, and moles of solvent water. This similarly in case of beaker T2, similarly we have mole fraction of solute H2SO4, we get in similar way 1.25 by 8.75, and mole fraction of solvent H2O 7.5 by H2 1.25, 7.5, 8 by 8.75. 8.75 is the total mole of solvent and solute present in beaker B, and also this total mole of solute and solvent in beaker B, and 1.25 is the mole of solute in beaker B, and 7.5 is the mole of solvent, that is H2O, in beaker B. bigger b. Therefore, this next page definition is on next page. Therefore, mole fraction can be formulated and generalized as mole fraction of solute XA equals to Na by Na plus Na, and mole fraction of solvent capital Na by small na plus capital Na, and mole fraction of solute plus mole fraction of solvent is equals to Na small na by small na plus capital Na, that is total mole in the denominator, and capital Na by total mole in the denominator, small na and capital Na, that is Na plus Na, and Na plus capital Na is equals to 1. That is mole fraction of solute XA plus mole fraction of solute B for solvent, mole fraction of solvent and mole fraction of solute is equals to 1. Therefore, and mole fraction of solute and mole fraction of solvent is the ratio of 2 moles. In the two cases are same, the ratio of 2 moles. Therefore, there is no unit of mole fraction. Therefore, mole fraction can be defined as the part of solute or solvent in mole out of the total quantity of solute and solvent in mole present in solution. In solution, sum of the mole fraction of solute and solvent is unity and has no unit, as the mole fraction is the ratio of 2 mole. Now again, mole fraction can be defined as the part of solute or solvent. Part of solute or solvent out of the total quantity of solute and solvent, out of the total quantity of solute and solvent in mole present in a solution. And in solution, sum of the mole fraction, that is XA and XB, is equals to is unity and has no unity, since this since the mole fraction bears a simple ratio of 2 moles. Now, mole concept and mole fraction in terms of partial pressure. 2 or more gas in a closed container without interacting each other produces a mixture of gas and exerted a pressure orthogonally on the walls or the face of the container. The pressure of the non-interacting mixture of gas is called total pressure. Assume that a mixture of argon and nitrogen is mixed and filled in the container. The two gas, argon and nitrogen, doesn't interact with each other and exert pressure on the walls of the different walls of the container. The individual pressure of nitrogen and individual pressure of argon exerted on the wall of the container is called partial pressure of the nitrogen or argon respectively. Now, the total pressure of the gaseous molecule is equal to the sum of the individual pressure of each gas exerted on the wall of the container. The individual pressure of each gas is called partial pressure. Individual pressure, actually. Now, it may be considered that a mixture of ideal gas, say gas 1, gas 2 and gas 3 and so on, contained in a vessel behaves ideally. Dalton's law states that total pressure of the gas contained in the vessel is equal to the sum of the partial pressure of each component. Each component means individual gas. Each component of gas contained in the vessels. Therefore, total pressure of the container P total equals to pressure of gas, partial pressure of gas 1, that is pressure of gas 1 exerted, exerted on the wall of the container, exerted pressure of the gas 2, pressure of the gas 3, plus dot dot plus so on. Dalton's law may be expressed in terms of mole fraction. The individual pressure, that is partial pressure, is equal to the mole fraction of the gas, mole fraction of the mixture of the gas, or total pressure of the gas. That is pressure, partial pressure of gas 1 equals to mole fraction of gas 1 into total pressure. Partial pressure of gas 2 equals to mole fraction of gas 2 of total pressure P total. Partial pressure of gas 3 equals to mole fraction of gas 3 into total pressure. Now, some numerical in the next page. Now, some numericals. Numericals 1. A 10-liter cylinder contains 7.60 grams of argon gas and 4.40 grams of nitrogen gas at 25 degrees centigrade. Calculate the partial pressure of each gas and the total pressure in the cylinder. Now, molar mass of argon 39.948 grams per mole, and therefore 7.60 grams of argon is equals to 7.60 by molar mass, that is 1.90 mole, represented by NaAr, moles of argon. Similarly, molar mass of nitrogen 14 grams per mole, and 4.40 gram of nitrogen, therefore is equals to 4.4 by 28, where 28 is the molar mass of nitrogen, is equals to 0.160 mole, represented as moles N2 nitrogen, that is number of moles of N2, 0.160 mole. Volume of cylinder 10 liter, gas factor, gas constant 0.821 atmosphere per liter per mole. The T temperature 25 degrees centigrade is equals to 298 Kelvin. Now, partial pressure of argon equals to NaR, PV equals to nRT. From PV equals to nRT, the partial pressure of argon is equals to moles of argon into RT by V. These parameters are given below, given here, and this is 4.650 atom. Now, and nitrogen, similarly, we get nitrogen 0.395 atom. Therefore, total pressure equals to partial pressures of argon and partial pressures of nitrogen, that is 4.650 and 0.391, that is equals to 5.041 atmospheric pressure or 1 atm. Next sum, calculate the mole fraction of water in a mixture of 12 grams of water, 108 grams of acetic acid and 92 grams of ethyl alcohol. Water 12 gram given, gram molar mass 18 gram, number of moles of water, therefore 12 by 18 is the gram molar mass of water, 0.667. Similarly, acetic acid 108 gram molar mass 60 gram, molar number of moles of water 108 by 60, 1.80. Ethyl alcohol 92 gram given, gram molecular mass 46 gram, number of moles of water sorry, number of ethyl alcohol here, and number of acetic acid. Acha. In here acetic acid, and then this is water. The number of ethyl alcohol 92 by 46. 46 is the gram molecular mass of ethyl alcohol. 92 by 46 is 2 moles. Therefore, mole fraction, total number of moles 0.67667, 1.80, 2.20. That is P1, P2 and P3. P of water, P of acetic acid, P of ethyl alcohol. And this is moles of. In moles of water, moles of acetic acid, and moles of ethyl alcohol. And this is moles of water. This is equals to 0.15. The moles of water, in case of acetic acid, 1.80 is the moles of acetic acid by total moles of water, acetic acid and ethyl alcohol 0.40, and mole fraction of ethyl alcohol 2.805, that is 0.667, plus this total mole of water, moles of acetic acid and moles of ethyl alcohol, we get 0.645. Next. Now, numerical 3. You place 2 liters of water in an open container in your dormitory room. The room has a volume of 4.25 in 10 to the power 4 liter. You seal the room and wait the water to evaporate. Will all the water evaporate at 25 degrees centigrade? And given that at 25 degrees centigrade, density of water is 0.997 grams per ml, and its vapor pressure is to 23.8 millimeter of mercury. Solution. From the above problem, it is considered that water molecule will evaporate and spread and fill the room till equilibrium reached in between the pressure of evaporated water molecules and the vapor pressure of water in the container is equals to 23.8 millimeter of mercury. That is, water molecules needed to evaporate, that the pressure reached the vapor pressure of the room reached 23.8 millimeter of mercury. Volume of water given 2 liter, volume of dormitory room 4.25 into 10 to the power 4 liter, pressure 23.8 millimeter mercury, 0. Is equals to 0.31 atmospheric pressure. Conversion is given here. T 25 degree centigrade, 298 is 298 Kelvin. Number of moles of water evaporated, NH2O equals to PV/RT. This relation comes from gas equation. PV equals to nRT. Data are given here. P equals to 0.31, V equals to this, and R equals to gas constant 0.821, and temperature T is 298 Kelvin is equals to 54 mole. Now we have to convert 54 mole into gram. That is 54 into 18 gram, since molar mass of water is 18 grams per mole. That is equals to 972 gram. Now 972 gram is to be converted into volume of water, dividing by density of water 0.997 grams per ml is equals to 0.975 ml, 0.975 liter, 0.975 ml. 975 ml or 0.975 liter. That is water evaporated. What it is evaporate? Water will evaporate less than the half of the water um, contains in the container. Therefore, this amount of water, 0.975 liter of water will evaporate, and 2 minus 0.975 equals to 1.025 liter of water will remain in container. Thank you.